In 1924, a German biochemist named Otto Warburg noticed something strange about cancer cells. They were eating wrong. Normal human cells take in glucose and burn it efficiently with oxygen to produce 36 units of cellular energy. Cancer cells were taking in glucose and fermenting it without oxygen to produce only 2 units of cellular energy. This was wasteful, wildly inefficient. It made no evolutionary sense. Why would a cell that is trying to grow faster than any other cell in the body choose the least efficient energy pathway? Warburg thought he had discovered the cause of cancer. He was wrong about that. But he had discovered something far more important. He had discovered that metabolism is strategy. The inefficient pathway that cancer cells use produces energy 40 times faster than the efficient pathway. It wastes fuel, but it generates energy at a rate that the efficient pathway cannot match. And when you are racing to divide faster than your neighbors for access to limited resources, speed beats efficiency. This is the Warbug Effect. And it is the mathematical signature of aggressive tumors. Now here is why this matters for how we think about investing. Every economic actor faces the same trade-off. You can optimize for efficiency, slow, steady, capital-preserving returns, minimal waste, sustainable over decades, or you can optimize for speed, high burn rate, fast growth, explosive expansion into available opportunity space. These are not just different strategies. They are different metabolic regimes, and cancer biology tells us exactly when each one wins. Warburg-style metabolism wins when resources are abundant and competition is intense. If glucose is everywhere, wasting it does not matter. What matters is converting glucose into new cells faster than your competitors. The tumor that burns fuel most inefficiently but divides most rapidly wins the colonization race. Efficient metabolism wins when resources are scarce and competition is low. If glucose is limited, you cannot afford to waste it. You need to extract every possible unit of energy from every molecule of fuel. The efficient cell survives the famine that kills the wasteful cell. This is the core insight. Metabolic strategy is not intrinsic to the cell. It is a response to the resource environment. And cells switch between metabolic regimes depending on what the environment demands. Now watch what this looks like in markets. During the decade from 2010 to 2021, interest rates were at zero. Capital was abundant. Investor appetite for risk was high. This was a metabolic environment of extreme abundance. Which strategy won? Warburg-style investing. Growth stocks that burned cash at extraordinary rates to capture market share. Startups with no profitability racing to dominate their verticals. Crypto protocols emitting massive token inflation to bootstrap network effects. All of these strategies were mathematically identical to aggressive tumors. High burn rate, fast expansion, inefficient capital use, and they all worked. Because the environment rewarded speed over efficiency. Then in 2022, interest rates rose. Capital became scarce. Investor appetite for risk contracted. The metabolic environment shifted from abundance to scarcity. And overnight, the Warburg-style companies began to fail. Not because their business models changed, because the environment that rewarded their metabolic strategy disappeared. Companies that had been valued at 50 times revenue collapsed to 3 times revenue. The cash-burning growth strategy that had dominated for a decade stopped working. The efficient, profit-generating companies that had been dismissed as boring during the abundance regime suddenly outperformed. This is the regime flip. Same companies, same fundamentals, same management, different metabolic environment, different winning strategy. In cancer biology, we now know that tumors use a mixed strategy. A tumor is not entirely Warburg or entirely efficient. It contains subpopulations of both metabolic regimes at all times. The aggressive subpopulation dominates during rapid expansion. The efficient subpopulation survives during nutrient depletion. Together, they form a metabolic ecosystem that can adapt to any environment. This is why single metabolism drugs rarely cure cancer. You can target glycolysis and kill the Warburg cells, but you select for the efficient cells, and vice versa. The only way to control a metabolically diverse tumor is to maintain pressure on both pathways simultaneously. Now apply this to portfolio construction. A portfolio that is entirely Warburg style is built for abundance regimes only. Growth stocks, speculative technology, high beta assets, venture capital. When the regime shifts, this portfolio dies. A portfolio that is entirely efficient style is built for scarcity regimes only. Dividend aristocrats, low beta value, investment-grade bonds, defensive sectors. When abundance returns, this portfolio underperforms for a decade while capital flows to speculative assets. The resilient portfolio maintains both metabolic regimes at all times. Not equal weight, but structural presence in both. Warburg positions capture the upside of abundance regimes. Efficient positions preserve capital during scarcity regimes. The critical decision is not which regime you are in. The critical decision is maintaining exposure across both so you can survive the transition. Because here is what Warburg himself did not know in 1924. Every regime transitions. Abundance becomes scarcity. Scarcity becomes abundance. The transition is the only mathematical certainty. And most portfolios fail not during the dominant regime, but during the transition between regimes. A portfolio built purely for abundance cannot survive the first scarcity shock. A portfolio built purely for scarcity cannot capture the first abundance expansion. A portfolio built for transition survives both. This is the metabolic principle in portfolio design. You're not trying to predict which regime you are in. You are building a metabolically diverse system that can shift between regimes without structural collapse. How do you measure whether your portfolio is metabolically diverse? Look at the capital intensity spectrum. Highly capital-efficient companies on one end, high burn rate companies on the other end. Plot your holdings across that spectrum. If everything clusters on one end, you have a metabolic monoculture. If positions span the full range, you have metabolic diversity. The Market Geometry Workbook includes a capital intensity classifier in the companion Excel file. It scores each holding as Warburg, balanced, or efficient and computes your portfolio's metabolic distribution. Download it using the link below. And if you are watching this series for the first time, start from Video 1. Video 1. Why therapies fail. Video 2. The math of market crashes. Video 3. The Fiedler value. Video 4. Cancer biology and market structure. Video 5. Adaptive therapy. Video 6. The mathematics of dormancy. Video 7. This video, the Warbug Effect. In the next video, we look at angiogenesis. Why do tumors build their own blood supply? Why do successful companies build their own distribution networks, their own payment rails, their own infrastructure? The mathematics of network formation under resource competition explains both. Subscribe so you do not miss it. This is advanced mathematics for everyone.